My name is Rajan Kumar. I'm the professor and chair of Mechanical and Aerospace Engineering Department here at FAMU FSU College of Engineering. And I also serve as the director for Florida Center for Advanced Aeropropulsion, AFCAP. This center basically serves a variety of purposes related to the technology development and workforce development in the aerospace sector.
My specific work focuses on the optimization and analysis of supersonic jet air intakes and how incoming flow conditions can impact the performance of the parent aircraft. This work is critical to ensuring that engine failures and other malfunctions that can potentially happen on supersonic aircraft are prevented.
We primarily focus on different aerospace applications, either using the wind tunnel or one of our other labs. In FCAP, we have 2 wind tunnels, the polysonic wind tunnel. In that wind tunnel, we can achieve a range of Mach numbers from relatively low speeds all the way up to Mach 5, which is 5 times the speed of sound. And in our low speed wind tunnel, it goes from around 5 meters per second all the way to 70 meters per second. It contributes to a safer world because it is directly related to the safety of the United States. It helps us create better vehicles that can help defend the U.S. at its best capacity.
My project focuses on a deflectable nose cone projectile. So the front of the nose of the projectile actually deflects either up or down and enhances the maneuverability of the projectile. It can also potentially increase its range as well. Here you're hands-on with your model. So you're able to do your own testing, you're able to see the entire process from designing your project, then you're hands-on with performing the wind tunnel experiments, and you process the data yourself. So we have a PIV system here. PIV stands for particle image velocimetry. It's where we shoot a high-speed laser into a really thin sheet and we put fog in the room and we are essentially able to illuminate the different particles and then capture pictures. So then we can actually recreate a 3D flow field of what the flow looks like on the back of a model.
So my project is looking at the inflow of the flow conditions going over a cavity flow, which is basically a cutout into the floor, similar to that of like a bed of a truck. So I look at the flow that comes into that and how that change in flow can change the characteristics of what happens in the cavity. My work contributes to a safer world because the aircrafts that either the military have that fly at the supersonic speeds, we want to ensure the safety of the pilots. And so by ensuring the safety of the pilots and their aircraft, that is helping us as well. The amount of resources that we have, especially all under one roof, is really unique. Also the connections that we make as students here, it's just a really great opportunity for people to learn more about their topic of interest and then also have the hands-on availability of all the resources we have.
We are doing research on optimizing aerodynamics for low speed and high speed aero vehicles, trying to make them more efficient, consuming less fuels, more friendly for the environment. And for the defense purposes, the vehicles that are aerodynamically optimized can fly faster, maneuver faster, so they will be more agile, and it will be more stealth for the defense purposes. So we're going to see a wing downstairs, flow is separated, and we are trying to delay that separation, and that will be beneficial for a plane taking off. That's one of the projects that we are working. In FCAP, we are able to find any facilities combined under one roof. That's the main advantage of us.
Over here, we do a variety of projects. Most of them are supported by Department of Defense, Air Force, Navy, Army. But we also work with a number of aerospace companies like Lockheed Martin, Northrop Grumman, Boeing. They come over here, they work with us, they test their products, so that way those products can be transitioned into the commercial market. We have some very unique facilities, whether we are talking about aerospace community or a variety of civil applications.